Hello and welcome to Calc Lesson number 21. This is going to be our second day of section 2.5, implicit differentiation. So let's start off with a quick recap of what we went over yesterday as far as our guidelines for implicit differentiation. The first thing we want to do is differentiate both sides of our equation with respect to x. We want to then collect all the terms involving dy dx on the left side of our equation and move everything else to the right side of the equation. Then we want to go ahead and actually factor out that dy dx from the left side of our equation until we can finally solve for dy dx. So for our first example today, we want to determine the slope of the tangent line to the graph of x squared plus 4y squared equals 4 at the given point, the square root of 2, negative 1 over the square root of 2. So we have a visual here, so we can see that we have this oval. Here we want to determine the slope of the tangent line. And those are some keywords that are telling us we're going to need to find the derivative, which remember is dy dx. And then we want to find it at a specific point, so then we're going to want to plug in our given point. So because we have an implicit equation, x squared plus 4y squared equals 4, we need to use implicit differentiation, which remember, we're taking our derivative with respect to x, but anytime our variables disagree, we are going to have to introduce that dy dx. So taking our derivative with respect to x of x squared, we can differentiate as normal, and we just get 2x, plus taking the derivative of 4y squared, our variables disagree, so we take our derivative, bringing our 2 down, we get 8y, but then we have to account for dy dx, and the derivative of our constant 4 is just 0. Continuing on with our steps, we want to keep our dy dx terms on the left side of our equation and move all other terms to the right. So I'm going to go ahead and actually subtract 2x from both sides. So I'm left with 8y dy dx equals negative 2x. And again, I'm just going to go ahead and continue to move terms to the opposite side. So I'm going to divide by 8y so that I can solve for dy dx. Simplifying my fraction there, I end up with negative x over 4y. And I'm not quite done because I'm not just finding the derivative. I want to find the slope of the tangent line at the point that they gave us, the square root of 2, negative 1 over the square root of 2. So now we're actually going to plug in that point, square root of 2, negative 1 over root 2, as our x and our y inside dy dx. So the slope at that given point, dy dx, equals negative, our x is the square root of 2, over 4 times our y, which is negative 1 over root 2. Now when we're dividing by that negative 1 over root 2, I'm going to flip that, so this is actually equal to negative square root of 2 over 4 times negative root 2 over 1. So dividing by negative 1 over root 2 is the same as multiplying by the reciprocal, which gives us negative times a negative gives us a positive. Square root of 2 squared is just 2 over 4, which gives us, simplifies down to just 1/2. So the slope of the tangent line at the point square root of 2, negative 1 over square root of 2, is just 1/2. And if we go ahead and investigate on our graph, here's our point of tangency, and our tangent line does seem to have a slope of about 1/2. Okay, example 2, we want to determine the slope of the graph of, and then we have this really exciting looking equation, 3 times the quantity x squared plus y squared, quantity squared, equals 100xy at the point 3, 1. So just looking at that equation, we can see there's going to be a lot happening. Remember, slope of the tangent line Whoops, my colors just got all funky. The slope is code for find derivative And then we're going to plug in our given point. Now looking at our equation, when we go to take this derivative, we have a lot we're going to need to do. On the left-hand side, we have 3 times a quantity squared. When we have that quantity, or that function, x squared plus y squared, inside that squared, that's going to be a chain rule problem. So when we go to take this derivative using implicit differentiation, we're going to need to use a chain rule. So let's start by doing that. Let's keep our 3 all the way on the outside. Taking our chain rule, we're going to bring our 2 down to the front, and that's going to go to a power of 1. We're going to leave our inside the same, x squared plus y squared. Then we're going to multiply by the derivative of the inside. Now taking the derivative of the inside, we would take the derivative of x squared would be 2x, and the derivative of y squared would be 2y, but our variables disagree, so dy dx. Whoops, close that bracket. That's just the left-hand side of my equation. On the right-hand side of my equation, we have the quantity 100x times y, and in order to take that derivative, we need to use our product rule. So taking that derivative, we would have our first 100x times the derivative of y with respect to x, dy dx, plus our second, which is y, times the derivative of our first, and the derivative of 100x would just be 100. So there we have the chain rule from the left-hand side and the product rule from the right-hand side. That's all of the differentiating. From here, we want to go ahead and simplify. Remember, our next step, our goal is to move all of our dy dx terms to the left and all of the rest of our terms to the right. So when we do this, when we go to simplify, I'm going to start just by multiplying this 3 times 2. So I have 6x squared plus y squared times 2x plus 2y dy dx. And that's equal to 100x dy dx plus 100y. Now in order to move our dy dx's all to one side, we need to get rid of this, or we need to distribute this 6x squared plus y squared through to both of these terms here. So this is going to become 6 times 2 gives us 12. Then we have our x times x squared plus y squared. And distributing it to our second term, 6 times 2 gives us positive 12. Then we have y times x squared plus y squared dy dx equals, and we can leave our right-hand side the same, 100x dy dx plus 100y. Now we want to move all of our dy dx terms to the left and leave all of our other terms on the right. So our dy dx terms include this one already on the left and this one. So to move it over, I'm going to actually subtract 100x dy dx from both sides. So my left-hand side is going to look like 12y times x squared plus y squared dy dx minus 100x dy dx equals, now I'm going to leave that 100y, but I need to move this term over to the other side, which I can do by subtracting 12x x squared plus y squared and doing the same thing on this side. Okay, we are almost done. From here, we want to actually take this dy dx and factor it out of our left-hand side. So we have dy dx on the outside, and what's left is 12y times x squared plus y squared minus 100x, and that's equal to 100y minus 12x times x squared plus y squared. And then our final step to get dy dx all by itself is going to just be to divide on both sides by that whole quantity, 12y x squared plus y squared minus 100x on both sides. So I'm going to write my derivative dy dx is equal to, now when I do this, I'm actually going to write it in a separate order. So I'm going to leave my numerator the same, 100y minus 12x x squared plus y squared over, and then I'm going to flip this around and write my negative 100x first plus 12y x squared plus y squared. Oh man, and we can actually simplify this a little bit more if we factor a 4 out of our numerator and our denominator. We can write our final dy, I need more room here, we can write our final dy dx as 25y minus 3x x squared plus y squared over negative 25x plus 3y x squared plus y squared. Now we could distribute that 3x through and that 3y through, but for right now I'm going to leave it because I know that I'm in a second going to actually go ahead and plug in. So take a second, absorb this, pause if you need to, go back through, and I'm going to flip the page over to a brand new blank slide so we can use that derivative to plug in our point. So as we continue with this very same problem, on our last slide we found our derivative and it's funky looking, and like I said in the last one, you could distribute that negative 3x through and that positive 3y through, but I'm going to leave it because this is going to be a little bit easier for me to do the mental math this way. Now from here we actually want to find the slope at the point 3, 1, so they're giving us our x and our y. Now remember, before when we weren't doing implicit, you would only need to plug in your x value, but here we need to plug in both our x and our y. So at the point 3, 1, the derivative is equal to, plugging in our x and our y, 25 times 1 minus 3 times 3 times 3 squared plus 1 squared over negative 25 times 3 plus 3 times 1 times, 3 squared plus 1 squared. Simplifying this just a little bit, 25 times 1 gives us 25, minus 3 times 3 is 9, and 3 squared plus 1 squared is just 10, over negative 25 times 3 is negative 75, plus 3 times 10. Continuing to simplify, we get 25 minus 90 just gives us a negative 65 over. Negative 75 plus 30 gives us a negative 45. And negative divided by a negative is going to give us a positive. And then 65 over 45 we can reduce down to a positive 13 over 9. So the slope of our graph at the point 3, 1, we can see here, has that slope of 13 over 9. Okay, so we're just going to practice a couple together. Here we want to find the slope of the tangent line. Remember, hint, hint, derivative at the given point. So here our function is xy equals 1 at the point 1, 1. So remember, because we want to find the slope of the tangent line, we are going to be taking the derivative. So the equation that we're taking the derivative of here is xy equals 1. Because we have x times y, that's going to need our product rule. So when we go to take our product rule, we're going to take our first x times the derivative of our second, and the derivative of y is just dy dx, plus our second y times the derivative of our first, and the derivative of x is just 1. And that's equal to the derivative of 1, which is just 0. From here, I'm going to leave my dy dx terms on the left and move everything else to the right. So subtracting y, I get x dy dx equals negative y. To get dy dx all by itself, we can divide by our x term. So we have dy dx equals negative y over x. Then we want to look at the point 1, 1. And we would plug in dy dx equals negative 1 over 1, which just gives us negative 1. And looking at the graph, we can confirm at the point 1, 1, our tangent line has a slope there of negative 1. Just a couple more, still finding the slope of that tangent line. Here, where our graph is 4 minus x times y squared equals x cubed, and I apologize, but if your teacher sent out a page for you to print, I may or may not have written this as x squared. So if that is the case, please go ahead and update that. Should say x cubed at the point 2, 2. Just like before, we want to go ahead and take our derivative on both our left side and our right side. Notice on our left side, though, we have the quantity 4 minus x times y squared, which means to take the derivative on the left-hand side, we need to use the product rule. Now to do this, I'm going to go ahead and write out my steps just to be sure I'm not missing anything. So here I want to take my first 4 minus x times the derivative of my second. So I'm going to write that as dx of y squared plus my second y squared times the derivative of my first dx of 4 minus x. And that's only my left-hand side, so then remember I still have to differentiate my right-hand side, and the derivative of x cubed, don't forget to make that change, is just 3x squared. Variables agree, so I don't need the dy dx or anything. In my next line, I'm just going to go ahead and actually do those two colored differentiations that I skipped before. So I'm going to leave my 4 minus x. Taking the derivative with respect to x of y squared, I get 2y dy dx plus y squared. The derivative of 4 minus x, derivative of 4 is just 0. Derivative of x is just, or negative x, I'm sorry, is just negative 1. And that's still equal to 3x squared. From here, I'm going to first start by actually moving this y squared quantity over, and I want to think of this times negative 1 really as being a negative y squared. So in order to move it over, I can actually add y squared to both sides, which makes my right-hand side 3x squared plus y squared. On my, and I'm going to leave my other side the same, I'm just going to scooch my 2y out front, so this becomes 2y times 4 minus x dy dx. Now from here, to get dy dx all by itself, I can actually just divide by this whole quantity. Whoops. So I can write dy dx as 3x squared plus y squared over 2y times 4 minus x. Again, you can simplify that, but because I know I'm going to be plugging in a second, I'm going to leave it just a little bit easier for my mental math. Here we're looking at the point 2, 2, so they give us an x and they give us a y that we need to plug in. Our derivative, dy dx, plugging in, we have 3 times 2 squared plus 2 squared over 2 times 2 times 4 minus 2. This gives us 3 times 4 plus 4 over 4 times 2. Gives us a 12 plus 4 over 8 is just 16 over 8, which means our derivative, dy dx, at the point 2, 2 is equal to 2. Looking at our graph at the point 2, 2, we see that we have a tangent line with a nice steep positive slope of 2. Okay, final problem, and just like that crazy one we did just a few examples ago, this one has a lot going on. Find the slope of the tangent line. That means we're going to be taking the derivative and plugging in our given point, but looking at our equation, we have the quantity x squared plus y squared equals 4x squared times y squared at the point 1, 1. So when we go ahead and take this derivative, just like we saw earlier, on the left-hand side, we have a quantity squared, which means we are going to be needing our chain rule. So when we go ahead and start differentiating, we're going to start by pulling that 2 down, leaving our inside the same to 1 less power. Inside stays as x squared plus y squared times the derivative of our inside. So the derivative of x squared is just 2x. The derivative of y squared is 2y, but our variables disagree, so we need dy dx. Remember, that's only our left-hand side. On the right-hand side, we have 4x squared times y. Because I have those two things being multiplied, I want to think of this as a product rule problem, where my first is 4x squared and my second is y. Following my product rule, I have my first 4x squared times the derivative of my second, and the derivative of y is just dy dx, plus my second, which is y, times the derivative of my first, and the derivative of 4x squared is just 8x. So we did a chain rule, and we did a product rule. Now we have to go ahead and simplify, very similar to what we did before. We're going to take this whole quantity, 2 times x squared plus y squared, and distribute it through. So first I'm going to multiply it to my 2x. So I get 4x times x squared plus y squared. And then to my second term, so I get plus 4y times x squared plus y squared, and then I still have that dy dx equals, and then I can just clean up my right-hand side a little bit by writing this as 4x squared dy dx plus 8xy. From here, I'm going to identify my two dy dx terms. Noticing that they're on two different sides, I'm going to do my best to move all my dy dx to the left and all my non-dy dx to the right. So keeping my first 4y times x squared plus y squared dy dx. On the left, I'm going to subtract my 4x squared dy dx. Then on my right-hand side, I'm going to leave my 8xy, but I'm going to subtract my 4x, x squared plus y squared. Now I can see that my dy dx terms are on the same side, so I can factor that out, dy dx, and I have left 4y times x squared plus y squared minus 4x squared, and that is equal to 8xy minus 4x times x squared plus y squared. Final step, just like before, is I can go ahead and divide, so I can write dy dx, leaving my numerator as 8xy minus 4x x squared plus y squared over, I'm going to switch it around again, so this becomes, I guess I could leave it, 4y x squared plus y squared minus 4x squared, and I notice that I have a lot of things in common there, like a 4, so if we factor a 4 out of there, we are left with dy dx equals 2xy minus x times x squared plus y squared over, taking our 4 out, we get y x squared plus y squared minus x squared. And you could simplify that. I'm going to leave mine because I know I'm going to be plugging in my point 1, 1, which I'm going to do on the next slide in just a second. Okay, so I just copied my derivative over, dy dx, and then like I said, you can work with it like this, or you can go ahead and distribute. Just be really careful. We know we're going to be plugging in our 0.11. So if you distribute, you just have to be really careful to make sure that you include all of your negatives. You don't make any simplifying mistake. So if you are comfortable plugging in your points here, then go ahead and do so. Otherwise, I mean, you could simplify, so you could write this as dy dx equals, this would be 2xy. Distributing our negative x, we would get minus x cubed minus xy squared, over distributing our y, we would get yx squared plus y cubed minus x squared. Again, there's just a lot of very similar looking values there. I'm going to separate that, so you want to be careful. It's hard to see. You want to be careful and make sure you distribute any and all negatives so you get your correct answer. From here, we want to find this at the 0.11. Remember, that's our x and our y that we can now plug in. So at that point, our derivative would be equal to 2 times 1 times 1 minus 1 cubed minus 1 times 1 squared all over 1 times 1, squared, plus 1 cubed minus 1 squared. There we go. This is going to take a little bit of patience. 2 times 1 is just 2. Minus 1 cubed is 1. Minus 1 times 1 is 1. Over 1 plus 1 minus 1. 2 minus 1 is 1 minus 1 is just 0 over 1, which simplifies all the way down to 0. And if we look at the 0.11, we notice that we do in fact have that horizontal tangent line. I hope you enjoyed your second day of implicit differentiation. I know these problems can get kind of funky, so just take it slow and be really careful. Tonight for homework, you have page 145, just a few, numbers 6 and 7, 29, 32, 33, 34, and 38. And as always, if you have questions, you can go ahead and reach out to your teacher.